The Steducentre Grade 9 A&A Exam Review, Maths.
Part 5.
In the quadrilateral ABCD, AB is parallel to DC. Complete the table below. 9.2.1, the statement, angle B1 is equal to what? And your reason is corresponding angles and AB is parallel to DC. And 9.2.2 is the angle D2 is equal to what? And your reason is alternative angles and AB is parallel to DC. Whenever we are working with angles, we need to remember fun. This is where we can see from the F that corresponding angles are equal. From the U, that the co-interior angles add up to 180 degrees. And from the N, that the alternative angles are equal. It's also important to remember that when we look at fun, we must be able to rotate it to see all the different ways that it could occur. In the quadrilateral ABCD, where AB was parallel to DC, we can see that from 9.2.1, B1 is equal to C because they are corresponding angles and AB is parallel to DC. This can be seen by the blue line. 9.2.2, the angle D2 is equal to B2. And that's because it's alternate angles and AB is parallel to DC. And this can be indicated by the red line. Question 9.3. In triangle ABC, angle A is equal to 60 degrees and angle C is equal to 40 degrees. Complete the table to calculate the size of B using the reason of the sum of angles of a triangle. It is important to know that the sum of angles of a triangle will always equal to 180 degrees. So, 180 degrees minus 60 minus 40 is going to give us what B is, which will be 80 degrees. In the figure, angle B2 is equal to 118 degrees and angle D2 is equal to 126 degrees. Complete the table to calculate the size of angle A. The statement is B1 is equal to 180 degrees minus 118 degrees, which is equal to 62 degrees. And B1, angle B1 plus angle A is equal to how many degrees? You need to include your reasons. It's important to remember that the exterior angle is always equal to the sum of the two opposite interior angles. So, if A and B are your two opposite interior angles, then your exterior angle D is equal to the sum of A plus B. In our figure, angle B2 was 118 degrees and D2 was 126 degrees. So B1 is equal to 180 degrees minus 118 degrees, which is equal to 62 degrees.
And this is because angles in a straight line equal to 180 degrees.
Angle B1 plus angle A is equal to D2, which is equal to 126 degrees because the exterior angle is equal to the sum of the interior opposite angles. Angle B1 plus angle A is equal to 126 degrees. 62 degrees plus A is equal to 126 degrees. So A is equal to 64 degrees.
Question 10.1. Write down 4 conditions for two triangles to be congruent. In order for it to be congruent, the following needs to be applicable. The 3 sides need to be equal. Side, side, side. Or the 2 sides and the included angle are equal. So it's side, included angle, side. Or two angles and the included side are equal. So you'll have the angle, side, angle. Or you can have the hypotenuse and one side that is equal. So right angle, hypotenuse, and side. So the four conditions for two triangles to be congruent are side, 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 side included angle, side, angle, angle, side, and right angle, hypotenuse, and side. Question 10.2. In triangle ABC, AT is perpendicular to BC and BT is equal to TC. Complete the table below to prove that triangle ABT is congruent to triangle ACT. The statement in triangle ABT and triangle ACT, what is given? We are given AT is perpendicular to BC. So what do we know? What is common? This will therefore prove that triangle ABT is congruent to triangle ACT. In the question, we can see that we are given BT is equal to TC. We are also given that T1 is equal to T2 because AT is perpendicular to BC. If you look at your triangles, you can see that AT is equal to AT because it is common for both angles. Therefore, triangle ABT is congruent to triangle ACT, side, included angle, side. Question 11.1. In triangle ABC below, DE is parallel to BC. Complete the table below to show that triangle ABC is similar to triangle ADE. In the triangle ABC and triangle ADE, there are three statements that we need to provide in order to prove that triangle ABC is similar to triangle ADE. It is always important to remember FUN. F to show that corresponding angles are equal, the U to show that co-interior angles add up to 180 degrees, and N in order to show that alternative angles are equal. So, in triangle ABC, where DE is parallel to BC, we can see that A is the common angle. We can also see that B and D2 are corresponding angles, therefore equal, and C and E2 are corresponding angles and are therefore equal. So, A is equal to A because it is common. B is equal to D2, corresponding angles, because DE is parallel to BC. And C is equal to E2, corresponding angles, because DE is parallel to BC. Therefore, triangle ABC is similar to triangle ADE. And my reason is angle, angle, angle. Question 11.2. If triangle DEF is similar to triangle KLM, and DE is equal to 2.5 centimeters, and EF is equal to 7 centimeters, and KL is equal to 5 centimeters, can you calculate the length of LM? One of the reasons that are provided is the proportionate sides of similar triangles. You need to use the given lengths to make an equation and make one of the unknown lengths the subject of the formula and solve for it in the same way you would solve for x. So we need to remember similar triangles, angle, angle, angle rule. Similar triangles are the exact same shape but different sizes. If two different triangles contain the exact same angles but are different sizes, then they are similar. We call this the Aaa rule. Triangle ABC is therefore similar to triangle DEF. It's always important to try and write down the information that is provided you in the question. So draw the triangle DEF. and draw the triangle KLM. Make a note to say that DE is equal to 2.5 centimeters. Make a note to see that EF is equal to 7 centimeters. And make a note that KL is equal to 5 centimeters. Now you can see what you need to calculate, which is LM. We are given KL over DE is equal to LM over EF, which is equal to KM over DF. This is the proportional sides of a triangle. So 5 over 2.5 is equal to LM divided by 7. We therefore can work out what the proportion is. 5 is double 2.5, so 14 is double 7. LM is equal to 7 times 5 divided by 2.5, which is equal to 14. Thank you for watching the Steducentre, turning ordinary learners into extraordinary leaders.